Welcome back, study buddies. Lesson 5 of our Python study group is here, and today we're diving into this explainer on the literal invisible magic that powers our entire digital world. Have you ever just stopped and thought about how incredibly fast everything happens on your devices? Well, today we're going to uncover the actual secret to that speed. We are officially moving way beyond just typing out lines of code, and we're stepping right into the mindset of a professional software engineer. Let's get into it. Look around for a second. Think about all the tech you've already interacted with today. Maybe you woke up, instantly unlocked your phone, and fired off a quick WhatsApp message, or maybe you Googled something, fell down a massive YouTube rabbit hole, ordered some lunch online, or even hit up ChatGPT for some homework help, right? Every single one of these actions feels instant. But behind the screen, man, there is a monumental amount of heavy lifting happening. And the crazy part, it's the sheer scale of it all. Every single one of those apps handles an unbelievable amount of data in literally a few seconds. When you send a text, your phone doesn't sweat searching through thousands of contacts. When you Google something, it searches billions of web pages in mere milliseconds. Billions! Your banking app pinpoints your exact account out of millions of customers instantly. It all happens so fast, you probably don't even blink. So you really have to wonder, how on earth are computers doing this so fast? Is it just because modern hardware is insanely powerful? I mean, raw computing power is definitely part of it, for sure. But actually, scratch that. It's not the whole story. If it were just about raw power, even our absolute fastest machines would eventually choke on the sheer volume of data they process daily. The real secret here isn't the hardware at all. It's something much, much more fundamental to how we actually build software. Okay, picture this. You've got a massive room filled with thousands of books. If they're all just dumped randomly in giant piles on the floor, finding one specific title is going to take you hours, maybe even days. But now, imagine those exact same books, arranged perfectly on shelves, grouped into neat categories, labeled clearly, everything in a logical spot. Finding that same book takes seconds. Notice how nothing about the books themselves changed? The only difference is the organization. It's like a giant puzzle that's already been solved for you. And that exact type of organization is how computers work. Which brings us to the absolute core concept of today's explainer, data structures. Computers process mind-boggling amounts of data every single day, and they literally have to organize it properly to work efficiently. So a data structure is really just a specialized format for organizing, processing, retrieving, and storing data. It's basically the digital equivalent of those neatly labeled bookshelves, making sure that when your computer needs a piece of information, it knows exactly where to grab it. Let's ground this in the real world for a sec. Imagine you aren't just learning Python anymore. Imagine you've just been promoted to lead software developer at a massive tech company, and your team is running a giant e-commerce store. This is where this stuff gets very real. The crucial thing you've got to understand here is the scale. Your platform doesn't have a few items. You're managing over 20 million unique products, and it's not just sitting there passively. Every single second, thousands of customers are searching for things, adding items to carts, running heavy payment transactions, loading thousands of reviews. The volume of activity happening every single millisecond is just staggering. Now, what if your application used a totally terrible data structure? Like those books just thrown on the floor. If your app had to search through all 20 million products one by one just to find a single pair of wireless headphones, well, it's a cascading disaster. The website crawls to a halt, customers get super frustrated staring at a spinning wheel, they abandon their carts, and they go straight to a competitor. A bad structural choice here literally costs the company real money every single second it's running. And this is exactly why tech giants like Google, Amazon, Apple, Netflix, why they care so deeply about organizing data intelligently. They don't just want code that works, they demand code that scales. When you pick the right data structure, you get blazing fast applications. That speed equals a better user experience, keeping customers happy. Plus, behind the scenes, you're lowering your operating costs because you're not wasting expensive server power. It makes maintenance a breeze, and crucially, it creates software that can seamlessly grow as millions of new users jump on board. Coach Timothy actually hits the nail on the head in our study materials. He says, in the technology industry, writing code that works is good. Writing code that works efficiently is even better. As beginners, it's so easy to fall into the trap of thinking programming is just memorizing syntax to make the computer do a thing. But the pros? They spend just as much time engineering efficient solutions, really thinking about how information is stored as they do typing out the code. Efficiency is the ultimate game changer that separates the novices from the pros. Now, you might be wondering, why are we learning this abstract stuff now before we've even built massive apps? Well, it's because our Python study group is explicitly designed to build your foundation first. Think about it. Every strong building begins with a solid foundation. You literally cannot build the 20th floor of a skyscraper before pouring the concrete for the ground floor. If you don't grasp how to organize data now, any big app you try to build later is just going to collapse under its own weight. And hey, look at how far you've come already. You've totally mastered the basics. You know how to write Python programs, create variables, juggle different data types, run calculations, build complex conditional logic, manipulate strings. You've proven you can write code that works. You have successfully built that ground floor. So now we're shifting gears to get you thinking like a professional. A pro doesn't just run their code, see the right output, and call it a day. No way. They immediately ask a critical follow-up question. Okay, sure it works, but can it solve the problem faster? Speed is the very first metric of a well-designed program because, in the real world, milliseconds absolutely matter. But it doesn't stop at speed. They're also asking, can this code run using fewer resources? Memory isn't infinite, right? If your program hogs all the computer's RAM just to do something simple, it's going to crash everything else. Efficient data structures keep that memory footprint tiny, so the whole system runs incredibly smoothly. And finally, the ultimate test. Can this handle scale? Will this code survive when one single user suddenly turns into 1 million concurrent users? All these massive questions, speed, memory, scalability, they are all answered by one single decision, choosing the exact right data structure for the job. Think of today's explainer a bit like learning to drive a car. You don't just instantly hop onto the freeway. First, you've got to understand what the steering wheel does, why the brakes matter, and how the rules of the road actually work. So you aren't going to see a ton of Python syntax today, because this is really about the ideas, learning the why before the how. We're mastering the mechanics of data, so when you do get behind the keyboard, you know exactly how to drive. As we move forward into specific data structures in the upcoming lessons, I want you to keep these 4 guiding questions in the back of your mind. Number 1, what specific problem is this data structure actually trying to solve? 2, why is it better than just tossing data into ordinary variables? 3, where have I seen this kind of organization out in the real world? And 4, how is this going to help me build better, faster software? Answering these ensures you're actually applying the concepts, not just cramming definitions for a test. So to wrap up this foundational explainer, I'm going to leave you with a quick thought experiment. Take a look at the tech you are using right this very second. Whether it's the browser tab you have open or the app you're using to check this out, what intelligent, invisible data structure do you think is secretly powering it right now to make it run so flawlessly? Keep that curiosity alive, guys, because understanding that invisible magic, well, that is your very first step to becoming a true expert software engineer.